All right, so here we go. Let's kind of quickly review 2, 3. We've been through several times. And the hard part in 2, 3 is just being able to recognize on equations. Is it a function? What's the domain? What's the range? And that comes with some practice. We're going to practice a little bit on that in a few minutes. But I want to talk to you about what we see in 2, 6. I didn't really address continuity with you last time, but let me make sure this part makes sense to you. If I were to ask you, what does it mean if something is continuous? What would you tell me? Anybody?
A straight line.
Okay, I think I hear what you're saying. Does it necessarily have to be a line?
No, it just continue.
Yeah, if something is continuous, I mean, because it could be, for instance, if we were like I just told you, I opened up your Kahoot quiz that you could do again between now and Thursday. So would you say that the time that you can take that quiz is continuous between now and when it ends Thursday night?
No.
Well,
Yes.
I think I would say yes, as far as it's continuous, that it's not that you can only sign on at 9 o'clock and then at noon and then at 3. Anytime, it is open continuously between now and Thursday night. So continuous simply means that there's no stop in the middle of it, that everything is connected. And so when we're talking graphs, then obviously we mean there are no gaps, there are no holes, there's no place where it stops and then starts again. And so this tells us that an informal way of identifying if something is continuous is if you can draw the graph over that interval and you can do it without lifting your pencil from the paper. That tells you that it is continuous. So to be able to determine if something is continuous, I'm going to kind of zoom in a little bit here. They gave us a couple of graphs to decide if we had a continuous graph or not. So if you looked at A, is that continuous? What do you guys say?
Yeah.
Okay, so Tate says yes. What does anybody else think?
Does the fact that the dot is white mean anything, or?
Oh, good question. Can somebody answer that? What do you think that open circle means?
It's not included.
It's not included. So do we have a gap or a hole here?
Gap.
We do. That point is not included. So that means this is a point of discontinuity. Okay? In other words, I would have to pick up my pencil, skip over this point, and not count it if I were trying to draw this whole figure. Now, how would I give the interval where this is continuous using interval notation? You remember when we talked about that? And remember, if I'm giving the interval of continuity, it's got to use my x values. It's got to use my domain. So think about this for a minute. What would be my smallest x value in this diagram?
Negative infinity.
Okay, do y'all agree with that?
Mm-hmm.
Okay, so it starts at negative infinity and it's going to go until where?
2.
Okay, so Jakarian says 2. Do y'all agree?
Yeah.
Okay, Tate agrees. Morgan, what do you think?
I agree.
Taylor, what about you?
I agree.
Okay, I got a question for you. Is 2 the value in the domain where that gap is? Is 2 the x value where the gap is?
Oh no, it's 0, right?
No.
Oh, that's the sneaky part. Remember we talked about
Oh,
this
I
last
see.
time. Yeah, you're watching what the Y's are doing to recognize where those changes happen, but your answers have to use the X values of those points. So that is the point 0, 2. It's 0 where the discontinuity occurs because I've got to use the X value. Does that make sense? Okay, now tell me how to close that off. Does that need a parentheses or a bracket?
Parentheses.
Y'all agree?
Yes.
Because if I used a bracket, what would it mean?
Included.
That it is included. Now, is that the only section that's continuous, or is there a second section that's continuous?
The second section, so you put a U.
Good. And then what is that second section going to look like?
0.
From 0 to positive infinity, and those need parentheses also. Make sense? Okay, that's my interval of continuity. That's where it's continuous. If you look at graph B, then do you see any problems there? Is this thing continuous over the whole thing, or do I have any points of discontinuity? What do you think?
It's continuous over the whole thing, right?
I don't know. What do you think, Logan? Do you agree? I'm not sure if he can hear me. Kasai, what about you? Do you agree? Does that look?
I'm not too sure. I can only catch bits of this. Can you hear me?
Yeah, I can hear you.
Hello?
Okay, so yeah, you may want to go back and review some in the recording if you get stuck. So I'll understand if I ask a question and you don't necessarily answer because maybe you can't hear me. So if I'm looking at graph B, does it look like there are any holes or gaps or places where it stops and then starts again? Or could I draw this whole thing with my pencil?
Yeah.
Yeah, this thing is continuous. So what would you put for your interval of continuity? What do you guys say? What would be my smallest X value that would go with this graph?
Negative infinity.
Negative infinity, all the way to
Positive infinity.
positive. Excellent, because I didn't have any of those holes in there. Okay, so we went through, we reviewed all the parent functions the last time. You need to study those and make sure you get that filled in from the video.
Go back. Can you go back?
Yeah, which one?
Like you had some writing, I didn't get that.
Well, this was,
there.
yeah, this was from a different class when we went over this. The whole thing is filled out in the video, so I would watch that. We just talked about in order to be a function, this is half of a sideways parabola, but if the other half was there, it wouldn't be a function because it wouldn't pass the vertical line test. So in order to be a function, we just use y is equal to the square root of x, which just gives us half of that curve. Okay, and then we talked about piecewise functions last time, and we covered some examples on that. So I want to talk just a little bit about section 2.7. That's what we're going to look at in a minute. But first, I want us to go to a quick review of whether we've got a function, what's the domain, and what's the range. So I've got a graph here, and the question is this a function? Now, they sort of didn't make this part very hard. Is it a function?
No.
Clearly, all of these choices have no, but why would you say this isn't a function? What's the
Still the
problem?
vertical line test.
Excellent. If I try to draw a vertical line, it's going to pass through more than one point, and that means it's not a function. Now, see if you can decide which one of these would be the correct domain and the correct range. And what we did last week, I want you guys to do this again. If you will look for your chat button, if you click on the bottom, you should see where you can find those 3 dots, more, and choose chat if you don't see it already on the bottom. And you're going to tell me if you pick A, B, C, or D as the correct answer on this. So you're picking out what would be the right range, what would be the right domain, and then type in either A, B, C, or D as your answer. And if you want to just click on where it says everyone, you can pull up my name so you're sending it to me privately. And that way, if you say, if you need to say, I really don't understand, you can tell me, and I'll be the only one that sees it. But if you think you know which one it is, then send that in. Okay, so I've got 1 answer so far. And as a quick reminder, my domain is which values, X's or Y's?
X.
Okay, so maybe that'll help a little bit. Okay, so I've got 2 answers so far. If you're stuck, send me a message that says I'm stuck, or you can unmute yourself and tell me, can we go over this? Okay, so I've had answers from 3 of you, and I'm thinking maybe we need to review this a little bit. So we said the domain means the X values. So if I look at this graph, my X's move from left to right. Okay, so if I'm going this direction, just a second. So if I'm going this direction, what is the first X value that I run into? What would be my, right here at -2 is going to be the first place that I'm going to find the graph, correct? And then if I keep on moving to the right, what's going to be the biggest X value that you see?
1.
So from -2 to +1, that's where X values are showing up on this graph, right? All right, so there are a couple of you that said, I'm not sure. Jakarian, you sent me an answer, so you don't say anything right now. And I want one of you other people who either didn't send a response or you said, I'm not sure. Does that get you down to a 50-50 on this multiple choice? If you understand that these are my X values, the correct answer's got to be one of 2 choices. What are they? Either, and y'all help Jakarian out, don't leave it to him. You guys tell me.
Either A or D, right?
Either A or D have the right domain. Agreed?
Yes.
Okay, so now I'm going to do the same thing with the Y's to figure out the range. So when you look at the graph, you've got to decide, is my range -infinity to +infinity, which is the answer on A, or is my range -7 to +5, which is the answer on D? Now type your answer and tell me what you think it is. We've gotten it down to a 50-50. Is the right answer going to be A, or is the right answer going to be D? Okay. So at this point, we're about half and half. So what I would like, Tate, will you help me out here? You first sent me A, and then you said, no, I meant D. Can you explain how you decided between those two, why you settled on D?
Because it ain't got the arrows that say it's like, continually going on, right?
Excellent answer. If there were arrows at the end, that would tell me this thing's going to keep on going, but there are closed circles. It stops right here, and it stops right here. The correct answer is D, because there are no arrows there. Does that make sense?
Yes.
Okay, because those are all the little things that I'm looking for that will help me figure this out. Okay. There we go. Now let's try another one of these. So we're going to just try to decide if this looks like this one is a function, and then we'll see if we can identify the domain and the range on it. Now, clearly this is another one that they didn't even give us the option. It says no. Can somebody tell me why you would say this one's not a function?
Because 5 coordinates, 5, 2, and 5, -2.
Excellent. Right here, this thing would not pass a vertical line test. Agreed? Now, if one of those had been an open circle and the other one was a closed circle, we would have been okay. It would have been a function. But because both of those are closed circles, I've got 2 points with the same x value. So that's why it's not a function. Now, I want you to see if you can figure out which one is the correct answer for the right domain and the right range. Can you do that for me?
For which one?
Oh, I'm sorry. Hold on. Okay. Can you see the graph? The one that's got like 3 curves?
Yes.
Okay. That's what I want you to do is look at this graph, and you're going to see if you can tell me what's the right domain, what's the right range.
So that's including all 3 of those arrows.
Yes, it takes all 3 of these pieces to get the whole graph. So just to kind of help everybody get started a little bit, I'm noticing on the domain, there's really only 2 choices, because on A, it says -infinity to 0, union 0 to infinity. B says -infinity to +infinity. And then C and D are the same thing as A. Okay, so the question becomes, the difference between A on the domain and B on the domain is what? Are they the same thing, or is there what's different about them? When I compare the domain on A with the domain on B, can you tell me what that would mean? Why?
Oh,
The one on A stops in the middle, right?
So the one on A says what value's not in my domain?
0.
0. It means I can't use 0 for X, but I could use anything else, right? B says I can use anything, including 0. Now look at your graph. Which one of those do you think is right?
A.
Okay, and why would you say that? Because
Because ain't no coordinate on 8. I mean on 0.
there you go. This is a vertical asymptote. This is squeezing closer to the y-axis as I get closer and closer to an x value of 0 on that section. This is squeezing closer and closer as I get closer to 0 coming from the right side, okay? So because this thing is just showing this arrow squeezing closer to it, it tells me I don't have 0 in this graph. So that means B can't be the right answer. Now that I've ruled that, narrowed it down for you that way, see if you can figure out what might be the right answer on the range. And there's a few more options on the range than there were on the domain. But we know the correct answer can't be B because the domain's not right. Let's see if you can pick out the right answer and then send it to me in a text when you think you know. And you know what? I'm looking at this and they've got a boo-boo. Oops, so sorry. Let's talk about this, okay? And I'll show you what the right answer should have been. If I'm coming from the bottom, okay, I see this, I'm going to have y values all the way until I get where? Is there a place where I'm going to get a gap in my graph and I'm not going to have some y values for a little bit?
Maybe so.
At -2, right here, this is the point 5, -2. And so what happens is I get here, this stops, and there is no piece of the graph that's going to show up between here and here, is there? Between there and the x-axis, there's no piece of the graph. Now, it picks back up at a +2 for this section, but what is this section doing? It's squeezing closer and closer to what?
Y-axis.
To actually, it's squeezing closer and closer to the y-axis this way, but it's squeezing closer and closer to the x-axis this way. And as I get closer to the x-axis, that means when I get to a y value of 0, I'm going to get some points in here. This should have had a negative sign on it, and then A would have been the right answer. They kind of messed up on that. Sorry, these were questions that the publisher put together. So I can see why you might have picked D. Several of you sent me an answer that said D because this part of it was right, but this should have had a 0 instead of a 2 for the second part. Does that sort of make sense?
A 0.
Yeah, because we're going to see this is going to squeeze closer and closer to the x-axis. So that means I get y values that would start at 0. So this one, if it has the negative with the 2, would be the right answer. Okay, now let me do this. I want us to go back to, oops, hang on. I'm going to give you another one to practice here in just a second. Oh, okay. Okay, so let's look at this and just see if we can figure out what would be the range on this function. So if it's asking me for the range, that's which part? You guys still there?
What?
Right
okay.
side.
So this is asking me for the range. Which part is that? My x's or my y's?
The Y.
Y.
Okay, so see if you can figure out, after I put in something for X, what are my Y values that are going to come back out? Now, what do these two bars mean?
Included. Oh, I mean,
When I put something inside bars like that, what does that mean?
Absolute
name of
value.
Absolute
value.
value. And when I'm taking the absolute value of something, what kind of number is going to come out? That's what you're going to ask yourself, okay? And remember, we've talked about a lot of times if you think of things in terms of positives and negatives and zero, that sometimes helps. So I want you to think about what will be the Y values that will come back out after I put in some number for X. I don't really care what numbers I'm putting in for X. I'm just going to figure out what are the only values that can come back out for Y. And when you think you know, send me either A, B, C, or D. Okay, I've got one answer.
I don't get it.
Okay, so maybe it's time to talk about it a little bit. So I want you to think for a minute. This is the same thing as saying Y is equal to the absolute value of X minus 2. Okay, so my question is, when I take the absolute, when I put in X, it's just going to give me some number inside these absolute value bars, right? I mean, X is just representing some number. So when I put in something for X and I take away 2, I'm going to take the absolute value of it. So it just means there's going to be some kind of number inside here. So if I've got a number inside there and I take the absolute value, first of all, can I get positives?
Yes.
When I take the absolute value of some number, it gives me back a positive, doesn't it? Okay. Can Y be negative? When I take the absolute value of something, can that
No.
answer then be negative? No,
No.
because the absolute value means I want the positive of what's in there. So I can't get any negatives. What about 0? Could it end up being 0?
Yeah.
Because if X were 2, what's 2 minus 2?
0.
0.
And what's the absolute value of 0?
0.
There you go. So here's what I figured out. I can't get negatives, but I can get 0 and I can get positive numbers. So looking at my options here, what would be the right answer?
B.
B would say I can use any
B.
number between 0 and 2. Can I not put in any number bigger than 2 for, can I not get a number back bigger than 2? I mean, what if I put in 10 for X? What's 10 minus 2?
8.
8. And what's the absolute value of 8?
8.
8. So I can get something bigger than 2. So it's not going to be that one.
It's D.
It's going to be D. That's the answer that has positives and 0. And 0 was included. Does that make sense?
Yeah, I get it.
This is how you got to think your way through it. If I'm looking for the range, then I'm looking for what will be the Y values coming out. Now, the answers are not on here, but could you tell me if I'd asked you about the domain for this? Do I have any restrictions on X?
No.
Are there only certain numbers I could put in for X, or can I put in any number I want?
Any number.
Because I can have positives inside absolute value bars, I can have negatives inside absolute value bars, and I can have 0. So my domain would have been negative infinity to positive infinity. Make sense?
Mm-hmm.
Okay, so here's what we're going to do. We're going to go back to the notes. And let me see. Here we go. All right. And I want us to talk just a little bit about what's called transformations. Okay. Transformations. So in other words, once we know what those parent functions look like, we can tell from how things change in the equation what's going to happen to it, if it's going to scoot over to the right or the left or up or down, or if it's going to get skinnier, if it's going to get fatter. So here's what we're going to talk about. If I were to ask you, do you know what the basic graph is going to be for y equals 2x squared? What shape will that be?
For you,
It's going to be a U shape, a parabola, because this is quadratic, right? What tells me it's quadratic?
square.
The fact that it's got x squared. Now, here's my question. It's not just y equals x squared, it's y equals 2 times x squared. What is that 2 going to do to the shape of the graph? Is it
Turn
going to make,
sideways
you think it's going to make it turn sideways
or upside down.
or upside down? Those are possibilities. It could also make it scoot up or down or right or left. It could make it look skinnier. It could make it look wider. Now I'm going to give you a clue. This is titled stretching and shrinking. So stretching, we're going to look at this in terms of what happens vertically. So if I'm stretching vertically, if you can kind of picture, if I grabbed hold top and bottom and I do this, what's it going to do to my shape? Is it going to make it skinnier? Is it going to make it wider? If I take something and I go this way with it. Like picture a big lump of Play-Doh. If I grab it and I do this, is it going to make it wider? Is it going to make it skinnier?
Skinnier.
There you go. So a vertical stretch will make something look thinner or skinnier. A vertical shrink will make something look how? What would be if I'm shrinking, yeah, when I squeeze down, that's going to make it spread out this way. So that's going to make it look wider. Okay, and make sure you write notes on this because you're going to need to understand. So here's my question. If there's a 2 in front of the x squared, which one of those things do you think it would make it do? Is it going to make it look narrower or skinnier? Or is it going to make it look wider?
Skinny.
I got 1 vote for skinny. What do you guys think? Well, let me show you real quick. I'm going to pull up the calculator. And in the y equals, I'm going to put in 2x squared. And that's going to be the blue line. Actually, let me do this. I just want to put in the x squared. This is the parent. Let's do it first. And then the red line is going to be the one that's the transformation. I'll put in the 2x squared. And we're going to see when we look at the red line compared to the blue line, did it get skinnier or did it go wider? All right, you guys ready? Let's look at the graph. There's the original. There's the transformation. So what did it do if I had a 2 in front of the x squared? Made it look skinnier. Very good. So what I'm going to ask you to do on the test and basically on your homework problems, I'm not going to ask you to graph this. I'm simply going to ask you to describe what that does to the graph. And that makes it a vertical stretch, which is going to make it look, and we can use skinnier, we can use narrower, we can use thinner, any of those will work, okay? Now, what if I put the number 1/2 in front of the x squared? What do you think it would do? Is it also going to make it look skinnier?
Yes, but less than 2.
Okay, so you think it's going to be skinnier, but not as skinny as 2 was? Anybody
Yeah.
else? Anybody else have any ideas? Well, let's take a peek. Okay, so I'm going to pull up the graphing calculator again. And this time, we're going to add, in parentheses, I'll put the 1/2, and then we'll have our x squared. Ooh, hang on. I got an extra 0 in there. How did I do that? Okay, oops, I know what I did. All right, so it's 1/2 x squared. Now let's look at the graph. Where is the black line? How does it look compared to the blue line?
And it got bigger.
Ah, it's actually wider, isn't it? Now, this is what's interesting about this, okay? This is called a vertical shrink. It made it look wider. Now, my question to you is this. What do you think I could look at to figure out whether it's going to be a vertical stretch or a vertical shrink? There's got to be something that when I see the equation that would tell me which way it's going to go. What do you think it is? And keep in mind that the original function, the parent function, is y equals 1 times x squared. Anybody see the pattern? What would be the rule? Okay, let's look at it this way. Let's say we're going to say our function is a times x squared, where a is some number, okay? If a is greater than 1, then it's a vertical stretch, which means it's going to make it look more narrow. But if a is less than 1, actually, let's put it this way. If the absolute value of a, because technically I might see a negative sign there. The negative sign has nothing to do with whether it's going to stretch or shrink. The negative sign is going to tell us something else about it. So let's just say the number part is less than 1. Then what does that tell me it's going to do? Is it going to be a stretch or a shrink?
Shrink.
It's a vertical shrink, which means it's going to look wider. Okay, so that's what you need to make sure you recognize, that number that's in front of your parent function. And it doesn't always have to be quadratic. It could be any of them. It could have the absolute value bars. It could be an x cubed. It could be square root of x. But if there's a number that's in front, in other words, it comes right after the equal sign, excuse me, that number is what you look at to decide if it's going to stretch your graph vertically or shrink your graph. And if you shrink it vertically, it makes it go wider. Okay, does that sort of make sense? You'll give me, okay. Now, we are not going to, well, why is that? Oh, I know why. Never mind. Okay. Sorry. We are not going to talk about horizontal stretches and shrinks. Those get kind of confusing. So I'm only going to ask you about a vertical stretch or a vertical shrink. There won't be any questions about horizontal ones. So you're going to end up not doing, oops, hold on. Hold it, hold it, hold it. I hit the wrong. Hold it. There we go. Hit the wrong button. Sorry, guys. Okay. You still there? Hello? Did I lose you?
Yeah.
Okay. Yeah, hit the wrong button. That was not good. So see if you can fill in this blank for me on vertical stretching and shrinking. As long as that number that's in front of the parent function is greater than 1, what do we call it? It's a vertical what?
Stretch.
Stretch, which is going to look which way? Narrower or wider?
Narrow.
Narrow. Good. And if it's between 0 and 1, or the absolute value is less than 1, then it's a vertical shrink, right?
Shrink.
Which is going to look wider. And then we're not going to do the horizontal part. Okay. Now, talk to me about when the negative sign shows up. What does the negative sign do to the graph? Like you guys told me before, that if we had y equals negative x squared, what do you know that would do to my graph?
Oh, it'll go the opposite way.
When you say it would go the opposite way, instead of being a
Like
U shape
down.
that opens up, it would open down. Very good. So what that does is it causes it to reflect over the x-axis. As long as it's something that is like the y equals x squared, or in this case, because it's absolute value of x, anybody remember if you were to describe using words what kind of shape that would be, what would you tell me? It's not a U shape, it's a V. You make sure you study those so you'll know. And if I were to reflect this, it means that because I have the 0.11, whenever I reflect it over the x-axis, it turns into 1, -1. If I have the 0.22, when I reflect it, it turns into 2, -2, and so on. And so all of these points are going to reflect down here, and that's what this guy is going to look like. Okay? So that's if the negative sign comes right after the equal. All right? In other words, whatever the whole function is gets a negative sign in front of it. Now, look at where the negative sign is on this next one.
Yeah.
Right here. That negative sign's not right after the equal sign. It's right in front of what?
X.
Just the x. So if it happens to just the x, then it reflects over not the x-axis, but the y-axis. Very good. And depending on your graph, that's going to make a difference. I really don't know why they chose this particular graph to show you, because there are some graphs that when you reflect like that, they end up looking the same. I want to show you a different one just so you can kind of get a feel for what this thing does. So I'm going to go back to the graph, and this time let me go to the y equals, and we're going to clear these out. And I want to pick this one, y equals x cubed. Okay, before I show you what this graph looks like, do you guys remember, if I were to ask you about the general shape, what would you tell me y equals x cubed should look like? Anybody remember? You can either think of it as like an S that gets stretched out this way, or some people describe it as a straight back chair. Here's what it looks like. You need to make sure you know that when you see y equals x cubed, you know that's what the graph is going to look like. Now, we said if there is a negative in front of the x, right? And let me do it this way. Oh, wait, it's not going to let me do it like that. It's going to make me do it this way. Negative x. Oh, hold on. Okay, this negative x, close my parentheses, cubed. Okay, because that's what we wanted to see, is what happens if we just change the sign of the x. If I look at the graph now, look at the red graph. This thing didn't flip over the x-axis, where this part up here matches this part down here, the whole thing flipped over the y-axis, and this part flipped over and went this direction, okay? And this part flipped over and became over here. Does that make sense? That's what happens if you just change the sign of the x. It's going to flip across the y-axis, okay? Got the idea? And this is all on the video, so you can go back and spend a little more time with it if you need to. I'm going to put that down. And let's look at one more thing, which would be, and I'm thinking I'm going to have to cut a few things with this, but let's talk about symmetry for a minute. Okay, do you guys, what is symmetry? In fact, this is just sort of a pet peeve of mine. I like things to be symmetric. So has anybody ever seen like a Nissan Cube? You know what I'm talking about?
Yeah.
That car that if you look at the back windshield, it's like one side of the car looks normal and the other side of the car, the windshield kind of wraps around. There's no symmetry on the back of it. That just drives me nuts. I don't know. I like things to be symmetric. So usually what we talk about with symmetry, if it's symmetry with respect to an axis, it means if I fold on that line, the halves are going to match up. Okay? And so the way we can test for symmetry with respect to an axis is we can change the sign of something. So for example, if we want to replace x with negative x, that's going to tell me if I have symmetry with respect to which axis do you think?
Why?
That's right. With respect to the y-axis. It means if I folded on the y-axis, the two halves would match up. Okay, and that's what we just saw a minute ago. I'll pull it back up on that graph. We changed the sign of x to be negative x, and it means if I folded, this original blue would land on top of this piece of red, and this original blue down here would land on top of that piece of red. And so if I can fold on an axis and they match up like that, I've got symmetry. And if it is symmetric to the y-axis, then it means when I fold on the y-axis, the halves are going to match up. And so what I do know is that when I have the point xy on the original graph, then I'm going to have negative x comma y on the graph as well. Okay, so positive x, negative x are going to map onto the same y value. Now, if I replace y with negative y, okay, then what do you think that's going to mean? I'm going to get symmetry with respect to what?
The x-axis.
The x-axis. And that's going to mean if I change the sign of y, then x negative y would also be on the graph, because if I fold it on the x-axis, those pieces are going to match up. Okay, so I could go in and test for symmetry if I make these replacements and see if they're going to match up. And I'm sort of thinking I'm going to modify this a little bit, and I'm not going to expect quite as much on this test as what I might normally do. I'm going to encourage you to watch this video so you'll get the rest of it. But I want to talk to you about the third kind of symmetry, and that's called symmetry with respect to the origin. And notice what it says here. If we're going to replace x with negative x and y with negative y at the same time, and it gives us back something that is equivalent to what we started with, that means we have symmetry with respect to the origin, or you might say rotational symmetry. So I want you to look at this little chart here real quickly. If I have symmetry to the x-axis, it means if I replace what with what, and it's on the graph.
Negative y.
That's right. If y gets replaced with negative y, in other words, I fold on the x-axis, the halves match up, I'm good. Y-axis means I replace what? Change the sign of x, and x gets replaced with negative x. If I fold on the y-axis and the halves match up, then I see that I've got symmetry with respect to the y-axis. But look at what symmetry to the origin is. I replace x with negative x and y with negative y at the same time.
Y with negative y.
Yeah, and this is not a folding symmetry. This is a rotational symmetry. In other words, if I stuck a pin at the origin and I spin this thing, kind of like a windmill. Have you ever had like a little pinwheel that you blow on it and it spins around? And the thing is, if I spin this around 180 degrees and it would look identical to what it looks like when I start. In other words, if this piece comes around and would match this piece down here, and this piece is going to match this piece, that tells me I have symmetry about the origin. It's not a folding symmetry, it is rotational. Does that make sense?
Mm-hmm.
Okay, so that's what you're going to be looking for, and that means if I replace x with negative x, and let me show you a quick example of when that works. So look at this one, y equals negative 2x cubed. If I change y to negative y, and I change x to negative x, I'm going to clean this thing up and see if it would clean up to be just like the original. So negative y is just negative y. Now on this side, I have negative 2 times, now what happens if I multiply negative x times negative x times negative x? What does that turn into? Positive or negative?
Negative x.
Because I've got 3 of those being multiplied together. So yeah, that ends up being a negative x to the third, right? Because negative x times negative x times negative x is still at negative, and then I have 3 of these x's being multiplied together. And what's a negative times a negative? I think I hear somebody trying to say it. Is that a positive?
Positive.
Negative times a negative is a positive. That's 2x to the third. So I got negative y equals positive 2x to the third. Now, initially, that doesn't look like it's the same thing as this, but what do you notice about the signs? My y is positive here, it's negative here. This side is negative in the original, and it's positive down here. Isn't it legal to multiply both sides of an equation by the same thing?
Yeah.
Yeah, so what if I multiply both sides by negative 1? When I do that, what does negative 1 times negative y turn into?
Positive.
Positive y. And what does negative 1 times positive 2x cubed turned into?
Negative 2x cubed.
That does match the original. That has symmetry to the origin. Okay? And I'm thinking we've probably covered as much as we ought to for today on this, but I'm going to encourage you, go back, look at the video. We're going to kind of go through some more of this next time because we still need to talk about even odd functions and translations, and I'm probably going to end up changing a few dates on some things as well. But especially these transformations where you're going to be translating things right, left, up, down. Look at those, and then we're going to go through this. Now, I do want to talk to you just a little bit about how I think we're going to do tests. So the way we're going to do tests is my plan is I'm going to put part of your test in Canvas, and I'll give you a window, probably a couple of days, that you'll have to log in to take the test, and you're only going to have maybe an hour, and that's being pretty generous, to do however many problems I have in there. I'm thinking at the most 10, okay? And you're going to type answers in for me, but you're also going to take a picture of your written work with your phone, and you're going to upload it and send it to me as a message. Does that make sense? Everybody knows how to do that part, right? Where you just take a picture with your phone and you could attach it to me in a message and send it to me, right?
My inbox. Okay.
Yeah, you can just do it in the inbox if you want, okay? Now, the other part, one day next week, probably Wednesday, what I'm thinking we'll do is, while we're having this Zoom meeting, can everybody turn your camera on for me for a minute? There we go. Okay, got Jakarian. Who else? There we go. I see Morgan's blue wall. And Kasai, there you are. Okay, still waiting on Tate and Taylor. Basically, here's the plan. I'll have a few questions, probably in the neighborhood of maybe no more than 10 at the most. It might not even be that many. That while we're having class, I'm going to have everybody turn your phone on, where your camera can show me you. You'll set it so that I don't see your ceiling or your floor, but I can actually see you. And then I'm going to send you probably on my screen the questions that I want you to answer for the second part of the test, which you will do while I'm watching you, and then you'll be able to upload that work and send it to me as well. Okay, so part of it is non-proctored, in that you're going to get to do it on Canvas at any time you want. I won't be watching you while you do it, but you still have to send me the written work. The other part you will do like this, where I'll be watching you, and like I said, it's not going to take that long. This is something where the part we're going to do together is probably going to be where I'm going to have a page that you've got maybe a graph, and I'm going to ask you to tell me, is this a function? What's the domain? What's the range? And you're going to write that down, and then you're going to send me the answer. And then maybe I'll give you a set of ordered pairs and ask you the same thing. And then maybe I'll give you an equation or a table, some of that kind of stuff from section 2.3 that won't take all that long. So you're going to want to practice those things. Okay? Any questions about that? That's going to be next week. Y'all are quiet. Okay, so I'm thinking at this point, we'll probably, do you want to go look at some homework questions together? Has anybody run into something that you say, I'm not sure how to do this, can we work on it?
Yeah.
Okay, so what we'll do now, since I've covered what I wanted to cover with you as far as just hitting some high points from the notes, and explaining how the test is going to work, and I know some of you've got some homework to catch up on, let's go ahead and go to some homework questions. So do you have anything in particular?
Yo.
Okay, so what do you want to look at?
2.6.
All right, let's go to some questions from 2.6. And let's see if I do this. 2.6. Which question?
4.
Oh, hold on. Why did it just do that? Oh, I know why it did that. Okay, hold on. I got to get out of this too long. Let me go back. And you said number 4?
Yes.
Okay, give me just a second. I got to go back in. It timed out on me. Okay, so just to make sure you guys are seeing my math lab on the screen, right?
Mm-hmm.
Okay, and then when this new window opened up, do you now see a problem that has some graphs on it? Can you see
Nope.
that? Nope. Okay, so
Nope.
let me go back and share that. Here we go. Okay. And we're going to go to problem 4. Now you can see the graphs, right?
Yep.
All right. So if we look at, whoo, where did that come from? Just a second. I'll get rid of that squiggle.
Oh, my bad. I didn't know you could see that on your screen.
Can you see
I
this
did the
now?
same thing.
Okay, so can you see it now?
Yeah. Yeah, it's
Okay.
gone.
All right, so it's gone now. Let's look at these graphs, and it's asking which one is not the graph of a function. So let's look at this and see if we can decide, is there one up here that you would say is not a function? And since they're all graphs, probably the easiest way to test is to use a what?
Line.
Yeah,
Whatever.
vertical line test. So let's see if you can tell me then.
C.
Which one did you say?
I said C.
He says C. Do y'all agree with that? Anybody
Yeah.
else?
Yeah.
I'm looking at C. Let me zoom in a little bit
Oh,
here.
no, C. Oh, different.
Oh, your graph. Okay, look at my screen for right now, because if you have a different one pulled up, then this way we're all looking at the same one. So looking at my screen, which one of mine, A through H, looks like it's not a function?
A.
Okay,
Yeah, A.
now he says A. Do y'all agree with that?
Yeah.
Because what's the problem? It's not going to pass the
Vertical line test.
vertical line test. Does that make sense? You guys are going to have to tell me. Does that make sense?
Yeah.
Okay, so A is the one that's not a function. Now, see if you could tell me what would be the equation that makes this graph. First of all, how would you describe the shape?
U.
It's a U shape, which means that it comes from what?
Squared.
It's got a square in
squared.
it. Now, the issue is if it were y equals x squared, which way does the U have to open on that?
Up.
Up. That's going to open up. If I put a negative in front of it, that makes it open down. This is opening
Down.
to the side. And what makes it open to the side is you switch the x and the y. So this becomes x equals y squared. That's what's going to make this open to the right. So if you type in x equals y squared, that's going to be the equation that would make that graph. Does that sort of make sense? A y equals x squared is a function, and it would open up or down. If you switch the x and the y, then x equals y squared is not a function because the u opens either to the right or the left.
See, I would never get it. Never got it.
Okay. Do we have anything else you want to look at while we're in 2.6? Anybody else have homework questions you want to go over?
No.
Think you're okay? Well, let me ask you this one. I've got number 5 on the screen, and it's saying which one is the identity function. Now, identity is another name for what?
Symmetry.
A linear function.
Linear.
Okay, so if it's linear, which one of these would you pick? A, B,
H.
C, D, E, F, G, H. Okay, I got a couple people saying H. What do you think, Morgan? Is that right?
I'm not sure.
Because linear means it's going to look like a line. Which one of these is a line?
H.
H. Okay. And what would be the equation that would make a line? What would be the parent function? What's the basic equation to get a line? Y equals what?
X.
That's it. That's why they call it the identity function, because y and x mean exactly the same thing. Okay, so y equals x is the parent for a linear function. Okay. What do you think about this? Which one would be y equals the cubed root of x? What does that cubed root function need to look like?
Yes.
It is a kind of an S shape. In fact, let's do this. On D, because we just looked at this guy a little bit ago, can somebody tell me what would be the equation that would make this one on D?
Y equals X squared.
Is that when y equals x squared?
Yes.
If it was y equals x squared, wouldn't it open up?
Oh, I mean X equals Y squared.
There you go. That one is x equals y squared because it opens to the side. Do you recognize C? What makes this half of a sideways parabola?
Oh, Y equals square root of X.
Excellent. Y equals the square root of x. Now, look at B. Did we see this guy before? That looks sort of like an S curve, and it gets stretched out vertically. Which one is
Y
that?
equals X cubed.
Excellent. By process of elimination, wouldn't that mean A is y equals the cubed root of x?
Yeah.
Yeah, because it is the S curve, but this one gets stretched out horizontally instead of vertically. Okay. And would there be any interval over this function on A where you would say the graph is decreasing? Does it decrease anywhere?
Yes.
Where would you say it decreases? Tell you what, can somebody help him out? What do you think? If I'm trying to decide where something's decreasing, when I'm looking at the graph, what am I looking for? Where the graph is doing what?
Decrease.
But what does that mean if it's decreasing? How do I tell if it's decreasing versus if it's increasing?
Going down.
Going down as I move which direction?
To the left.
Left to right.
From left to right. Okay, now look at this graph. Is there any place, if I'm going from left to right, that this thing is going to be going down?
No.
No.
So how would you answer this question? Is there any interval that's decreasing?
No.
No.
Very good. It increases on the whole thing. Okay? All right. So any other homework questions, or do we feel like we kind of have a handle on what we're doing for the moment?
Yep, I got it.
Okay. Don't forget, you can always contact me if you need any tutoring with Zoom. We can do that. And if you feel like you're having